Welcome back, everybody. We're almost done. We got 3 sections left. We're there. Today, I guess I should always put what class I'm looking at here. We're at Math 54. This is on 8.6. And this is on de Moivre's theorem. Moivre. De Moivre. I think it's Moivre. Maybe the R is silent. I'm pretty sure it's French. So, what is this theorem? If R cosine theta plus I sine theta is a complex number, and if n is any real number, then R cosine theta plus I sine theta, all of that to the nth power, equals R to the n cosine n theta plus I sine n theta. And if you wanted to look at it in compact form, R cis theta to the n equals R to the n cis n theta. Okay, so example. We'll have square root of 2 plus I root 2 fifth power. Write the answer in rectangular form. Well, what can I do? I want to kind of make it look like one of these up here. Right? So like I'm gonna use a big box for the fifth power and try to get that to look like something up there. If I factor out the square root 2, I have 1 plus I. kind of angle is that making? Is that really helpful as it is? It might be easier to leave the root two in and do something like this. I need that fifth power there. But if I have this as root two over two, I know what angle it is, right? But if I do that, maybe I need to add a two on the outside. I can't just divide by two without changing anything. So sometimes trying that obvious thing doesn't help. This wasn't helpful. So here we aim for an angle. We recognize. From or based on root two. What angle would this be? 45. It's 45 degrees, right? So this is like 2 times cosine of 45 degrees plus I sine 45 degrees. And a plus in there. But and using Moivre's formula, this turns into 2 to the 5th power. Because R is 2 here. And theta is 45 degrees. Then we have cosine of 5 times 45 degrees. Plus I sine of 5 times 45 degrees. So what is 2 to the 5th power? 2, 4, 8, 16, 32. 5 times 45 is 225. And that's not in rectangular form, so where are we? 225, this would be 180. And so to get to 225 is another 45 degrees. We're at the 45 degree mark in quadrant 3. What is cosine and sine there?
Negative 2 over 2, root 2 over 2.
They're both negative root 2 over 2. And if I distribute the 32, I've got negative 16 root 2 minus 16I root 2. What if you didn't recognize right away this step right here? What if you didn't recognize that? Let's tackle this the other way, because this is faster. This gets us into something we recognize, otherwise we gotta use the formulas that connect rectangular to polar or trigonometric. So let's go back to the same thing, √2 plus I√2. If you don't recognize the shortcut. We need to find R and we need to find theta. R is based off the square root of x squared plus y squared. Where this is in the form x plus iy. And theta would be tangent inverse of y over x. So if we did that. I have square root of 2 squared. Plus square root of 2 squared inside another square root for r. Which looks weird, but when you start cleaning it up, it's not too bad. This is square root of 2 plus 2. Which is the square root of 4. And we get r equals 2, and we can see that's true from up here. That's what we got up there. Theta is tangent inverse. Y over x, √2 over √2. Or tangent inverse of 1. So theta is 45 degrees, and that's the reference angle theta. You have to pick the right quadrant. Or pick correct quadrant based on rectangular coordinates. And these were both positive. First quadrant. So it's not just a reference angle of 45, it is 45. But that's what we had up here. Sometimes recognizing this looks something similar to what we need, you can go with it, otherwise you gotta work out the formulas and find out what they are. Any questions? Let me give you guys one. Just try. Let's go with (1/2) minus I√3 over 2 cubed. Try to work that out. And then we'll do it together. Any notes today, Davis? Forgot your shit, didn't you?
Like.
Do you need some paper and like pencil?
was something right here.
Yeah. If you don't recognize the angle and stuff, you gotta do what we're doing up here, don't get. Pros, just start grinding shit up. It's a formula here, you're just plugging stuff in and calculator stuff with there. Like you went left and came back from the right. Okay.
It's the right hand.
Alright, so what do we get? Is 1/4 plus 3/4. R equals the square root of 1, which is 1. Tangent inverse of negative root 3/2 over 1/2. Which is tangent inverse of negative root 3. Just by multiplying top and bottom by 2/1 on the inside. What angle is that? 60 degrees. Should be negative 60 degrees with the negative root 3. So what would the real theta be?
300.
Theta would be 300. Let's work it both ways using the -60 and the 300, make sure we get the same answer either way. It's a good thing to give it a try. So what we have here is we've got one cis 60 to the third power. No, I'm sorry, -60. Or we have one cis 300. To the third power. Well, this should be doing, if we follow the approach, we do 1 to the third. And then cis of n times our angle. So I end up getting 1 cis -180. What's cosine of -180 though?
-1.
And what is sine of -180?
0.
0. I'm gonna put I times 0. Just to point out that this just simplifies to -1. That's deep. Is that what we get if we do the other one? We do this, we've got 1 cubed cis of 3 times 300 degrees. Which is cosine 900 plus I sine 900. Let's see, 900 minus 360. I'm gonna try to get down to an angle I know. That is 540. Let's get down, subtract another 360. 180. So this is really, I need a plus in there. Cosine of 180 plus I sine of 180. And that's the same. -1 plus I times 0 or -1. So we got the same thing either way. Any questions? All right. Next topic. This is just it's work. We did, if you did the homework or started the homework from last session. This is gonna be a whole lot easier. If you haven't, this is gonna be like fucking trying to learn Latin. Like this is all based on what we did from 8.5. Alright, so the next part is doing not powers of complex numbers, but roots of complex numbers. And we're gonna look at like the nth root. That way we're not picking a particular root. Just like we didn't pick a particular power in the last section. Is it like that was the nth power or nth exponent? We're gonna just take the nth root. If we take the nth root of x plus yi. It is going to lead to another complex number. Now, a or b might be 0. It's not gonna be both. But it could be the case. Another way of looking at this is x plus yi equals a plus bi to the nth power. What can we do that, rather than trying to work with the exponent thing and try to do a shortcut? Or rather than working with the powers, we have a formula for this. If we are looking for. Because the nth root. Right here, this is x plus yi. To the 1 over n. So if I can write this as. R cosine theta plus I sine theta. To the 1 over n. I'm showing you how you can come up with this formula if you don't remember it. This is not necessarily the most intuitive one. You do need to remember the previous one, the exponent one. This turns into r to the 1 over n power. Times cosine. Theta over n. Plus I sine theta over n. And this is the nth root of r. And I'm gonna use alpha here for this. The book uses alpha. And we'll talk about what alpha is in a second. But this is. This right here. Alpha is gonna be, well, if we're working in degrees. It looks like theta over n is part of it. But. Every loop that has the same thing still works also. So it's gonna be 360 degrees K. Times K. Where K is an integer. Up to n minus 1, we don't want an infinite number of loops around. And if we're looking at it in radians. Theta plus 2 pi k over n. Again, where k is the same thing. And the only thing you gotta remember if you try to rederive the formula starting with the exponent rule. Is that theta over n needs to have every increment until you basically filled up 2 pi.
Symbol represents the entire equation. That'll, it's all represented.
It's representing the entire angle.
Value of.
Yeah. So this part here gives us. The multiples of. I don't wanna say multiple, because it's not a multiple of theta. It gives us the. Full set of roots. And I think the first example is gonna be one that is the best answer. This will make more sense when we do the first example. Cause I'll give you something that you know the root for. put that where we can leave it and see it. Maybe write the shortcut notation will help. R cis theta to the one over n equals the nth root of R cis alpha. Where alpha is that. So. What are the roots of -8? If we go by our algebra approach. God, that looks terrible. This is like saying x equals the cube root of -8. Which is the cube root of -1 times the cube root of 8. What's the cube root of -1?
I,
No, that's the square root of -1. I was wondering if the odd power would throw someone off. It's just -1. If we did -1 cubed. We still get -1. So if I take the cube root of both sides, I'm gonna get -1. What's the cube root of 8? 2. So our answer here would be -2. That's what if you put in the calculator, what's the cube root of -8? This is the answer you're gonna get, -2. But this is also like if I cube both sides, this is like saying x cubed equals -8. Okay? The reason why I say that is when you write it like this, oh, I want to use the color. The exponent shows the number of possible solutions. There may be repetition on the solutions, but here it shows the number of solutions. So there should be 3 solutions. -2 is the only real solution. There are 2 complex ones. So let's find the 2 complex roots. And we're gonna use this up here. God, that one, it's kind of dark. Okay, so what we need to start off doing is we need to write -8 in terms of r cis theta. So what are we looking at here? -8 when x equals -8, we're over here, right? There's no I portion. This is just a real number. So this is kind of like -8 plus 0i. And we're looking at the cube root of that. If you need to, we can find R. By doing square root of -8 squared plus 0 squared. Which is the square root of 64, which is 8. If you drew the picture, you would see that it's 8. Without having to use any triangles or anything, it's just a straight shot. What is the angle there?
180.
180. We'll also look at the pi version. Do it both ways. So this is 8 cis 180. To the 1/3 power. Or 8 cis pi. Alright, so using this formula right here. It turns into the nth root of r. Which is the cube root of r, cube root of 8. Times cis. 180. Plus. 360k. Over 3. And we get 2 cis 60 degrees plus 120 degrees K. K is gonna go all the way up to n minus 1. K is 0, 1, and 2. Which means we have 3 answers. We have 2 cis 60. We have 2 cis 180. And we have 2 cis 300. This is the one we already got. -2. Well, let's write it the right way. 2 times -1 plus I times 0 is -2. We had that.
Excuse me, Hefe, could you move it up a little bit?
Yeah, sorry.
Thanks.
This one is 2 times cosine of 60. What is cosine of 60?
1/2.
1/2. What is sine of 60?
3/2.
Root 3/2. So -2 is one answer. It looks like 1 plus I root 3 is another answer. And if we do this one, we've got 2 times. Cosine of 300 is still 1/2. But I sine of 300 is negative root 3/2. So we have 1 minus I root 3. Yeah,
The K values are there because those are the only K values available within the first
up to n minus 1.
up to.
So before we do the pi one, x cubed equals -8 is line saying x cubed plus 8 equals 0. And these are like the roots or factors of it. This is like saying x plus 1 plus I root 3. No, minus. It's like saying x equals each one of these. And so I get x minus 1 minus I root 3 equals 0. This is x plus 2 equals 0. This is x minus 1 plus I root 3 equals 0. And I can put those all together, and x cubed plus 8 factors into x plus 2, x minus 1 minus I root 3, x minus 1 plus I root 3. That's like factoring it, but you'd never be able to factor that like that directly. The answers here are the -2, 1 plus I root 3, and 1 minus I root 3. I'm just trying to show some additional stuff here. This is kind of crazy. We have a formula for the roots of the sum of cubes. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. That's a formula from algebra. Well, this is x cubed plus 8 is x cubed plus 2 cubed. So following that formula, we have x plus 2, x squared minus 2x plus 4. Apparently, this factors into x minus 1 minus I root 3, x minus 1 plus I root 3. But you would never have gotten that without using complex form. It sounds like bullshit, right?
Well, I mean, I'm confused as to why, if we knew from the beginning that we needed a root of 3, couldn't we just do this?
Could you have gone from here to here though?
We know that.
There's no way in hell you were gonna start with x squared minus 2x plus 4 and end up with that.
I'm not.
I can guarantee it, I'll give you like x cubed plus 27 and ask you to come up with a fucking answer here, and you're not gonna get it. You're not gonna factor this to this. We don't have a way of doing it, this doesn't factor, there's nothing, well, it doesn't look like there's anything that multiplies. But we can show that it does work. Let's multiply this out. I got x squared minus x plus I root 3 or I x root 3. Then I'll do the -1. I've got -1 times x is -x. -1 times -1 is +1. And -1 times I root 3 is -I root 3. And finally, we'll do the -I root 3. -I root 3 times x is -I x root 3. I'll put it underneath the other ones like that. -1 times -1 is +1. And -I root 3 times that is -I squared times root 3 squared. So I've got x squared minus 2x plus 2 Did I not write?
How did you get a second -1 times -1? That's where I'm confused.
I fucked up somewhere, because this one should have canceled out. Let's see. Squared minus x. Here, so we got -1 times x is that, -1 times -1 is that. This one was wrong. -I√3 times that, this was +1 root, or I√3. Sorry. That was not another +1. So that's only +1 right there. Those cancel out, those canceled out. And we have -I²3. What is I²?
-1.
-1. So that term there turns into +3. And we did end up getting our x² minus 2x plus 4, we multiplied it out. So this does factor to this, but there's no way you're gonna get that without using de Moivre's theorem with the fraction exponent. Like it took doing this. That's crazy. I said we'd go back and make sure we do the 8 cis pi one though. That gives us the cube root, we get cube root of 8. Which is 2 times cis, we got pi plus 2 pi k over 3. Which is gonna, and k equals 0, 1, and 2. So you get 2 cis pi over 3. We get 2 cis pi over 3 plus 2 pi over 3. Which is 2 cis pi. And we get 2 cis pi over 3 plus k equals 2, 2 times 2 pi is 4 pi over 3, which is 2 cis 5 pi over 3. Putting them all next to each other. That's our 60-degree one. That's our 180-degree one that we did earlier, and that's our 300-degree one that we did on previous page. Let me give you guys one to try real quick. We got a couple more, let's take a 10-minute break. I'll pause here. Alright, during break, Davis asked an important question. Where the hell did I get 3 roots? And like I had originally said, what are the roots of -8? I didn't specify that we were looking for 3 of them. With 3 of them, there's gonna be 3 cube roots. This is the better question of what I should have been doing. So like, I have no way of go back and redo, I'm not gonna redo 20 minutes of fucking video later on. So if you're watching this video later, that's what's going on. Let's take a look at ones that you know the answers to. What are the 2 square roots of 4? You can do it do it algebraically. And B, use the mob. So 2 square roots of 4 is like starting off with x squared equals 4. And taking the square root, and what do we get?
Two and negative
2 and negative 2, I was like, oh my god, someone hopefully knows the answer to this. Alright, now let's do it with Des Moines. Let's rewrite 4 in terms of r cis theta. Showing a picture of where that is in a complex plane. That was like 4 plus 0 I. So we're over here at 4 0. And we're looking for the square root or to the 1/2 power. Now, you can either go with along the lines of square root. 4 squared plus 0 squared. Which is square root of 16, which is 4. And this is theta equals 0. So if I rewrite this in the radians approach. I have 4 to the 1/2 power. Times cosine of alpha. Where alpha equals 0 plus 2 pi k over 2. And k is 0 or 1. Does that connect what with what we were doing before? That formula? Which means alpha equals 0 or. When k equals 1, I've got 2 pi times 1 over 2 is pi. 0 or pi. So I have 2 cosine 0. Or cis 0, sorry. Or 2 cis pi. This is 2 cosine 0 plus I sine 0. This is 2 cosine pi plus I sine pi. What is cosine of 0?
1.
And sine of 0?
0.
0. So that's just the 2. And this one, what is cosine of pi?
Negative 1.
Negative 1. And sine of pi? Negative 2. So yeah, that 2 answers we got using Des Moines is the same as this. Algebraically, for like a square root is definitely easier.
But the Mons is kind of potentially infinitely expanding.
I gave something that was easy to find, this was like an easy problem. Not all of them, like the last problem we did, you can't get the answers algebraically. This is just one of those examples, you can get the answer algebraically and compare off and see.
But kind of, I guess what you could through this system kind of like get the 16 roots of 357.
Yeah,
You really want.
if you really want
It
to,
is kind of expanding.
we'll do a 6th root or the 6 roots of something as the last problem here. Let me give you guys, find the two square roots of -9. And you can use the approach we did here. And do it both ways, you should be able to get the answer both ways. Coffee break, but definitely the easier one here, as long as you remember how to do it. It's like, oh, that was too long ago. What do we get algebraically? What is that? It has a value. Yeah, plus or minus 3i. So that's what we're aiming for, that's what we hopefully get here. We're doing -9, there's no complex part of that. So that's like -9 plus 0i to the 1/2, that's what we're looking for. Using De Moivre's theorem. So r is gonna be the square root of -9 squared plus 0 squared. Which is the square root of 81. Which is 9. Where is -9? -9's over here. 0i. So we have an angle of 180 degrees. You could have gone now with tangent inverse as well. So writing this, we'll do the 180 degrees version here. We have 9 is my r, so we're doing 9 cis 180 to the 1/2. That is the square root of 9 times cis alpha, where alpha is 180 plus 360k over 2 Rn, which is going to be 90 plus 180k. K equals 0 to 1, 0 and 1. So we're gonna have 90 degrees and 270 degrees. So we have 3 cis 90 and 3 cis 270. Three cosine of 90 plus 3i sine of 90 is just 3i. Cosine of 90 is 0 and sine of 90 is 1. And this is 3 cosine 270 plus 3i sine 270. That's 0 and -1, so we get a -3i there. So it works on square roots both of positive and negative numbers just fine, we just did it with 2 different examples. When you guys are done writing, we're gonna tie this all in graphically and do a couple more examples. I think when you see the graphical approach, I think this is gonna make this, it's not really a graphical approach, but what the results are graphically. Things are gonna be like, oh, I think I can take advantage, I can use that. Alright, let's take a look at it graphically. I'm gonna go back to the x cubed one that we did first. Where I confused the shit out of everybody. So like, let's look at graphics of it. The 3 cube roots of -8. We had started off with 8 cis. 180 and then taking the cube root of that. And that led to 2 cis 60 plus 360k over 3. Which was 2 cis 60 degrees plus 120 degrees K. K equals 0, 1, and 2. Those are the answers we had. And that ended up giving us 60, 180, and 300. Graphically. Let's see, 60 degrees is right about there. I don't want to, let's do like that, there we go. That's another 120 degrees from there. So maybe I'll do this in a red line. A red line. And we go another 120 degrees from there. And a red line. Once you find what this starting angle is, you're really just breaking up the circle into the number of roots. You guys, so you see that? We broke up the circle into 3 wedges. This is like wedge 1, wedge 2, wedge 3, 3 roots. 3 wedges. When we did x squared equals 4. We wanted the 2 roots of 4. We had ended up getting, this was 2 cis 0. I did it in radians, not plus 2 pi k over 2, which was 2 cis pi k. So 2 cis 0 and 2 cis pi. We start off with our 0 degrees. I want to break up the pi into k wedges. 2 roots, 2 wedges. Half a pi each, right? Which means my other one has got to be make the half a pi. This had a radius of 2. When we did the 2 roots of -9. We ended up with 2 cis 90 plus 180k. And we got 90 and 270 there. But graphically, if we just go straight to the 90 degrees, our first one. I put my wedge, my first slice here. I need to break this up into 2, there's 2 roots, 2 wedges, half a pi each. I make the other half a pi here. So I would see without even jumping, like having to do this stuff here. If I just see how many wedges I've got, I can figure out or confirm. You should confirm, not use this as a shortcut, but confirm that should make sense. We're gonna use this idea to help us on the next two problems. We're gonna use it to make sure like what we're doing makes sense. You guys ready?
Mm-hmm.
People are still writing. So we are gonna find the four fourth roots. Negative 128. Minus 128 I root 3. So we're basically looking at putting that to the 1/4. Now, what quadrant graphically is that in? That's X, that's Y, they're both negative, we're somewhere down here. So we're in quadrant 3. I don't know if I have the right angle, I just drew it in quadrant 3. Now, we can find R by doing, R is the square root of negative 128 squared. Plus negative 128 root 3 squared. Oh god, that's some calculator shit. Let's see if I can find it another way. If I factored out a 128. I have negative 1 minus I root 3. I don't have an angle that works with 1 and root 3, but I do have one that works with 1/2. So if I take negative 1/2 minus I root 3 over 2. I have a 1/2 in here, I gotta multiply the outside by 2 to counter the 1/2. And this is looking like 256. Cosine of 1/2, negative 1/2, and sine of negative 1/2. The reference angle is 60, so this is 240. 2 cis 240.
Yeah.
I'm guessing when we throw this in a calculator, we get 256. If you can't work this out doing it this way, you gotta do the slow fucking long approach on the calculator with this. Just make sure you don't fuck it up. 128 times the square root of 3 equals. I will square that and add 128 squared to that. I'm getting R equals the square root of 65,536. When I take the square root of that, I do indeed get 256. Make sure I get that angle, I've got tangent theta equals y over x. Negative 128 root 3 over negative 128. Which is positive root 3. So if I did tangent inverse of that. I'm in degree mode, I need to switch to radians. I probably could have done it, I know I could have done it that way. No, I want it in degree mode, that's not helpful. Tangent inverse of square root of 3. There we go, 60 degrees. That's my reference angle. I know it's in quadrant 3, so that tells me theta is 240. And so I do get 256. Cis 240. That's what we're gonna put to the 1/4 power. So I'm gonna have 256. The fourth root of that. Times cis. Of 240 plus 360K over 4. This is 4 cis. 60 degrees. Plus 90 degrees K. So 60 degrees is right about there. And I've got a radius of 4. That almost look, shit, that almost looks like 45, let's say it's fucking 60, let's say I do a better graph than that.
Mhm.
I had 4 roots, so 4 wedges. Which means I need 4 pie slices. I'm cutting this into 4s. I'm just gonna do a line going the opposite direction and then. Try to do one that. Cuts this into 4s. I don't know if I cut it into 4s very well. Each one of these should be rotated 90 degrees. That's cutting the 360 into 4. So just looking at it graphically without like going by the K. I got 60 plus 90 is 150. $150 plus 90 is 240. And 240 plus 90 is 330. That's just pulling it from the graph. God, my graph does not look good. Do more like, that's more like a 60 degree right there. That's a little bit better. That's probably more than 60 degrees, but it doesn't look like 45 at least. Doing this approach. I have 60 plus 0 K. 60 plus 90 times. Not, I'm sorry, not 0 K, 90 times 0. This is 60 plus 90 times 1. 60 plus 90 times 2. 60 plus 90 times 3. That's doing K equals 0, 1, 2, 3. Do those angles match up?
Yeah.
Looks like it, right? So we didn't start in polar answers, we don't wanna end in polar answers. For cis 60. We have 4 times cosine of 60. Which is 1/2. Plus I sine of 60 is √3/2. This is 2 plus 2i √3. I do 4 cis 150. Remember that is cosine 150 plus I sine 150. Cosine of 150 is
-3/2.
negative root 3 over 2. What's sine of 150?
1/2.
1/2. So this is negative 2 root 3 plus 2i. We do 4 cis 240. Again, we have a reference angle of 60, but now these are both negative. This should be negative 1/2 and minus I root 3 over 2. So we're gonna get negative 2 minus 2i root 3. And 4 cis 330. That's a reference angle of 30 degrees. Cosine of 30 degrees is root 3 over 2. And sine is negative there, so negative I times 1/2. And so we get 2 root 3 minus 2i. And those are the 4 roots of that value. 4 fourth roots. Going back here, even before we did the 4th root. I've got my 240 degrees here. Right? And then I could have done the 4 wedges directly from there. You can actually get this graph all the way back to the beginning. You want to do this approach to make sure you get the right answers. But seeing it pictorially right away is helpful. And sometimes, like graphically, you're not gonna be able to like figure out what it is. Like if we had the 7th root, can you break up 360 in the 7ths and figure it out very well? No, that's some fucking obscure shit. Any questions on that one? It takes some practice. Let's find all complex solutions of x to the 6th plus I equals 0. So that's like x to the 6th equals negative I, or x equals the 6th root of negative I. Even before I get started, I can see negative I is straight down. And I should be breaking this up into 6 roots, 6 wedges. So 360 over 6 is 60 degrees. Just rotate 60 degrees from there. Rotate 60 from there. 60 from there. Sixty from there. And 60 from there. When we're done solving this problem, we should be able to get those right there.
And we can just know that that's gonna be 60 degrees for each wedge because 360 divided by 6.
360 divided by 6, yeah. So I'm seeing, just graphically, I see 270. Add 60 to that, I get 330. Add 60 to that, I get 390, which is 30 degrees. Add 60 to that, I get 90 degrees. Another 60 is 150. And then 210. So I'm thinking when I'm done, these are my angles when I'm done. But we're gonna show it doing it the other way. We are looking at the 6th root of negative I, which is 0 minus I to the 1/6. So R is square root of 0 squared plus negative 1 squared, which is just gonna give us 1. And if I try to do tangent theta here. Your calculator is not gonna do that. You have to know that is negative, or that is 270 degrees. I wonder if I think my angles are off. Because when I do it the right way, I get 1 to the 1/6, which is 1. Cis of 270 plus 360 K over 6. And 270 over 6 is not one of those I's. I think my intuition was off. It is off. This is 45 degrees plus 60 degrees K. So my intuition was off. I didn't start at 60, I didn't start at 270, I should have started at 45. So apparently my picture is wrong. That's the 45-degree mark. And I'm going 60 degrees from there. So that would hit at 105. 165. 225. 285. And 315. That was wrong. My initial guess was off. So don't always just assume you can start with the graph and go jump to it graphically. At least get the first line doing this right here, 270/6, that's what I failed to do, was divide by the 6 to get my starting point. So we gotta go through and find that. Find sys 45. And this is calculator work at this point. And I'll probably, let's not do that, because that's just a boring waste of time in here. Should be 345. Make sure you're adding 60 degrees each time. I know these though, that's square root of 2/2 plus I root 2/2. And this one is negative square root of 2/2 minus I root 2/2. These are gonna be fucking decimals. So I made the erroneous assumption, I tricked myself in my head to start with 270. I should have, if I wanted to do the graphical approach, divide 270 by the number of roots. 270/6 would have told me to start at 45. Other than that, that's all I got for you. Have a good day.
Thanks, Efe.
Oh.
Bye.